Welcome to another episode of the Your Longevity Blueprint podcast. Today, my guest is Dr. Kara Fitzgerald, who is engaged in clinical research on DNA methylation using diet and lifestyle intervention developed in her virtual and in-person functional medicine clinic. She's the author of Younger You, Reduce Your Bioage and Live Longer, Better, a groundbreaking work detailing an 8-week study that resulted in a 3-year reversal of biologic aging and the step-by-step program that will help you live better and longer. In her quest for personalized health care for all, she leads clients through her Younger You program and has her Younger You companion cookbook, Better Broths and Healing Tonics, which she just said came out today before we started recording. Dr. Fitzgerald is on faculty at the Institute for Functional Medicine and is an IFM certified practitioner. She regularly lectures internationally and hosts the podcast New Frontiers in Functional Medicine. She received her doctorate in naturopathic medicine from the National University of Natural Medicine in Oregon and is in private practice in Sandy Hook, Connecticut. Welcome to the show, Dr. Fitzgerald.
Thank you. It's great to be with you today.
Well, tell my listeners your story, how you became so fascinated with methylation.
Yeah. Well, we when I did my postdoctorate in a clinical, so I had a residency in a clinical setting, but I was primarily in a laboratory. I was in a clinical laboratory, Metametrics, which was eventually
Sure.
purchased by Genova Diagnostics. So,
Yep.
if you're in functional medicine, you're familiar with those two labs. And my director was a nutritional biochemist, or is. His name is Richard Lord. He's a dear friend, and he's just my main mentor in life. And when I had my interview with him for this position, he was obsessed with homocysteine. And so out the gate, my postgraduate training was centered in methylation. So
Sure.
anybody who knows, homocysteine sits at the switch between our methylation cycle and then our transsulfuration cycle. Homocysteine rises and falls based on, really how well we're making the methyl donor S-adenosylmethionine. So so homocysteine is a surrogate marker of total body methylation activity. So, years ago, I was thinking about it. And of course, in the laboratory, we measured, a lot of the constituents within the methylation cycle. We were considering single nucleotide polymorphisms and their influence on the methylation cycle. So that was early on in my training. When I left the lab, when I finished my training there and set out on my own, it was about 2013 that I hunkered down and started to read uh, the literature coming out on epigenetics. And I want to say, so just to define for your
Please. Yeah.
listeners, epi is above, genetics, the genome, our genetic
Hmm.
material. So above the genome, it's the biochemical mechanisms, processes that regulate what genes are on and what genes are off. This is the field of epigenetics, and it's incredibly important. And it's grown in our appreciation of its importance has grown, really like logarithmically. We thought that genes were our destiny not that long ago. We really thought that the genetic hand we were dealt, would dictate our fate. And it was really in
Thankfully,
the yeah, thankfully
thankfully,
that's not yeah, yes. We're now learning that we sit in the driver's seat of influencing epigenetics, of influencing which that back to methylation. One of the key ways, one of the very best studied and perhaps most influential of all of the 100 plus epigenetic marks is something called DNA methylation. So we're now back to methylation, but we're thinking about it specifically in relation to regulating gene expression. And so, flash forward, finish my postdoc. I'm in clinical practice. I started to read these papers, and the bulk of the science in 2013 was coming out on cancer. And so it turns out cancer very efficiently hijacks our epigenetics from us. So the tumor microenvironment takes over gene expression, takes gene expression from us, and starts to dictate which genes are on and off. And it naturally, the tumor microenvironment, it wants to grow and proliferate. So it turns off genes that protect us from cancer, and it turns on genes that drive cancer forward. And a fundamental mechanism is DNA methylation. So cancer is taking over DNA methylation. And it actually turns out that the chronic diseases of aging, like all of them, sort of have some of this imbalanced DNA methylation happening. Going back to homocysteine, as a clinician, the way that we lower that is by giving B12 and folate, and and maybe sometimes we use choline or betaine. There's other nutrients that we might use. The question to me, looking at this cancer epigenetic data, was could providing somebody folate and B12, I mean, this was the fundamental question almost 10 years ago for me, actually, if in somebody who's vulnerable to cancer or who already has cancer, could this be giving these methyl donors, could this actually be problematic? And that question stopped me in my tracks. And it turns out that in some cases, yes, because going back to it, it could sort of give the tumor microenvironment the ingredients to turn off genes that protect us. So we may be imbalancing DNA methylation activity by some of the nutrients that we prescribe, trying to ensure health. And I think that the possibility for that being true does exist. And so at that time, I teamed up with my then nutrition director, Romilly Hodges, and we released what we called the DNA methylate, not the, excuse me, the methylation diet and lifestyle. This was way back. It came out. We launched it in 2016, and we both presented on it at the Institute for Functional Medicine's annual conference. So we decided that we would take a food forward approach. We need those methyl donors. We need folate, we need B12, we need betaine, we need choline, we need all of them. And we need them in robust amounts. So we need these, but how do we do it as safely as possible? There's no evidence in the literature that, consumption of any amount of food-based folates, so lots of leafy greens, etc., nuts, seeds, mushrooms, choline and eggs, even liver. There's no evidence that demonstrates it could promote imbalanced methylation. So this food forward approach seemed essential. And there was another piece that we discovered, and that is combining methyl donors, be them in supplement form or food, with these compounds that we call methylation adaptogens. This includes green tea, et cetera, and curcumin. I know we'll come back to this, so I want to condense my story because it's already getting too long. We would help to direct how methylation happens in the body. So long story, excessively long. The way that I got into this was being a curious mind in functional medicine and having this laboratory background. And then actually being able to study the program that we put together that I know we'll tease out. And I guess I need to connect that to aging. So should I keep going or should I stop?
Let's back up, and this is good.
Sorry.
So you've had interest in methylation essentially from the very beginning, is what you're saying.
From the yes,
and then you had curiosity about cancer, whatnot, and how can we apply this from a lifestyle standpoint? Which, yes, I want to dive into that, but I feel like we should define methylation and back up here. So let's define methylation and then differentiate that from DNA methylation too, because I know listeners are probably thinking, because we do a lot of Dutch testing, a lot of urine hormone testing. In my practice, they're thinking, oh, I've had my methylation tested on my urine hormone assessment, which that's similar, but also different. And so they may be thinking, oh, I'm a poor methylator or a great methylator based on their methylation of estrogens that they know. So let's kind of define methylation and then differentiate that from DNA methylation.
Yeah, awesome. Good, thanks. And feel free to cut me off at any time if I go too into the rabbit hole like I just did. So going back to homocysteine and the methylation cycle, there's a compound that we make in that methylation cycle. Again, that's where we use folate and B12, called S-adenosine methionine. And that's our universal methyl donor. And that compound, SAM, as he's known for short, or she's known for short, is a cofactor in the hundreds of methylation reactions that are happening in our body all of the time, all over the place. So methylation is incredibly fundamental. I mean, sometimes I'll draw the analogy that it's like oxygen, to breathing, so methylation, it's essential. We need it. We need it to be functioning. We can't survive without it. It's a
It's
key player
constantly
in.
happening. Yes.
Mhm.
Yep.
Yeah. And so there's hundreds of methylation reactions happening. So one of them is the methylation of estrogen. So we make, we take one of the end step for two types of estrogen is to methylate them, and that renders them inert and harmless. Those intermediate estrogens can sometimes be problematic. So we want our body to be able to methylate. Actually, even beyond being harmless, those methylated estrogens can actually be protective to us too. So we want to make sure we're moving estrogen that way. We want to make sure we're making compounds like choline and dopamine, adrenaline, um, even histamine. Actually, we metabolize histamine using methylation. So many incredibly important compounds. Methylation is involved in either making the compound or eliminating the compound.
Sure.
And when we go over to looking at DNA, there's another methyltransferase enzyme there that puts so that SAM will give the enzyme a methyl group, and a methyl group is just it's such a simple compound. It's a carbon with three hydrogens. It's just essential, simple, ubiquitous, and the SAM will donate it. So just like we detox estrogen or we methylate estrogen, we put a SAM on the estrogen structure. We take SAM and we'll put it onto our DNA. So right on the cytosine, if anybody remembers their bases, right in the fifth position of the cytosine, we will put a methyl group. In the scientific literature, these methyl groups on DNA are denoted, look like a red lollipop. And when there are a lot of methyl groups on a gene, you see lots of red lollipops, that gene is inhibited from being turned on. It's not able to be, transcription is not able to get in there. Transcription factor, the protein that will will help translate a gene, is not available. So the lollipops kind of interrupt structurally, and that gene is inhibited. Conversely, we can either inhibit lollipops from being placed on a gene, or we can even remove them. And when the promoter region of a gene has few or no lollipops, that gene's going to be able to be turned on and expressed. So a very fundamental goal for wellness would be, I want to have all the good genes on, the ones that are associated with best health and longevity, et cetera, and I want to have the bad genes turned off. Now, and just as I said regarding cancer, we know that cancer will hijack where those red lollipops are going and turn off genes that we want on. It will turn off protective genes. Very, very well documented that this happens. There's hypermethylation of good guy genes. And then conversely, it will turn on bad guy genes, oncogenes, genes that will allow cancer to proliferate. And so we need to ask ourselves, as functional medicine providers, are we adequately balancing methylation in this individual? If you are looking at your Dutch test and you see that you're not making those 2-methoxyestrogens, you're not methylating your estrogens very well, does that translate to DNA methylation? Certainly, it has the potential to. We know that homocysteine, so an elevated homocysteine, which is a evidence that you're not methylating well and need B12 and folate, is associated with less methylation in DNA, is associated with imbalanced DNA methylation. So, somebody who's got poor methylation happening at the estrogens, poor catechol O-methyltransferase activity, certainly that could translate into negative changes
Sure.
to DNA methylation.
Sure. Sure. I'm going to take some words from your book because you have this great analogy. I mean, you're talking well about you in your book. You say that our DNA, aka our genome, is our hardware that can be damaged, but that can be repaired with software. Software being epigenetics, right?
Mhm.
So our whole conversation today is really revolving around empowering our listeners to debug this software, right? So
Yes.
improving their DNA methylation with likely the practices you implemented in the study that you were referring to. So let's kind of go back to that and let's break that down.
Yeah.
And tell us like what foods are important to improve methylation, whatnot. So let's bring it back to your
Mhm.
study now.
Sure. So we need As we age, we actually methylate less efficiently. So you can see that when you measure homocysteine on some of your older patient population, we'll routinely see that that homocysteine is higher. Um, as we age, we don't methylate as robustly as we did when we were young. We also actually start to methylate in an imbalanced way. We turn genes are on that we don't want on, genes are off that we want to be on. Methylation just becomes wonky, is the scientific term, as we age, and which incidentally looks like the chronic diseases of aging. If you look at methylation happening, it looks like cancer, it looks like cardiovascular disease. It's kind of crazy and it's extremely interesting. So we want to be giving our body two really incredibly important pieces of information in the form of what we call epinutrients. And these are foods that influence epigenetics. We call them epinutrients. We need to lavish our body with foods that include methyl donors. So beets with betaine, eggs with choline, liver with choline. Liver is a multivitamin in a food matrix. Liver has fabulous amounts of B12, folate, choline, betaine. It also has a collection of minerals and more. Um, Lots of leafy greens, um, seeds like pumpkin seeds, sunflower seeds, nuts, um, mushrooms. Mushrooms are brilliant. Shiitake, enoki, maitake, etc. Even button mushrooms have choline in them. So this will make methyl donors. This will let us put those red lollipops down on genes. But we also want to make sure that these red lollipops are going to influence genes we want to influence. And the way that I think that we do that with food is through this collection of nutrients that we call methylation adaptogens. So again, these are both epinutrients, but the methyl donors actually have nutrients that will push methylation forward, help make red lollipops, and then the adaptogens seem to sort of direct where that red lollipop is placed. And these methylation
Is that like the
adaptogens,
backdoor approach that you say in your book, or no? Or is that different?
it's different.
Different.
So
Okay.
yeah, and I'll come back to the backdoor
Okay.
approach.
Yeah, yeah.
So the adaptogens will direct. We don't want a tumor suppressor gene that protects us from cancer to be inhibited, but we want the oncogenes to be hypermethylated and shut off. We want our pro-inflammatory genes to be hypermethylated and inhibited, that kind of thing.
Sure, sure.
Foods that we know and love, nutrients that we've been using time immemorial, seem to direct epigenetic traffic, direct these red lollipops. That includes curcumin, green tea, quercetin, which we've all been, using a lot
Mhm.
in the COVID pandemic. Um, Blueberries. So if we look at foods, all of the colorful berries, citrus, uh, rosemary. So many different spices, actually. Most spices, actually, probably really all spices, have nutrients that are these epigenetic um, methylation adaptogens. And so in rosemary, there's something called rosmarinic acid. It's actually found in thyme. It's found in a host of different spices. Ginger, garlic um, have this ability to just kind of make sure methylation on the genome is happening in an optimal way. So um, whenever we're taking these methyl donor rich foods, we want to accompany them with these methylation adaptogens. So have
Sure.
your big green salad and throw some rosemary on it, do some turmeric based dressing. Actually, there's an infinite way that we can combine epinutrients. And I should say, I'm so sort of gaga about this topic. In the book, I have a 30-page epinutrient appendix. It's the only nutrient appendix of its kind where I list the known epinutrients in the literature at the time of the book writing and food sources. So anybody can make sure that they're eating epinutrients really at every meal and even in every forkful. So you're getting some methyl donor information and you're also getting
Wow.
these
Yeah.
this
Awesome.
epinutrient. Yeah, it's so
Is
cool.
that
I
also in your
want
cookbook then, or what?
Yes, it
Like,
is. Yeah, it is. It's in the cookbook as well. That actually our appendix isn't in the cookbook. You'll need the younger you to get the appendix, but the
sure.
cookbook is just full of epinutrients. In every recipe, they're packed with epinutrients. Diet, in addition to diet, lifestyle influences what's happening. Exercise, if you're doing it, you're going to favorably influence DNA methylation, if you're doing it and you're doing it correctly. Sleep. If you're sleeping well, you'll favorably influence methylation. If you're not, you're going to damage it. Stress. Stress will have negative influence on methylation, actually, really pretty profoundly. We can think about biochemical methylation and what happens with, adrenaline and stuff like that. But at the level of DNA methylation, stress can dysregulate what's happening there. And conversely, meditation, turning the volume down on stress can have a favorable influence. So
Makes
these
sense. Yeah.
they're not directly in the methylation cycle, but they're these factors that play a profound role in how well methylation is actually being carried out in the body. And so our program and what we studied was the diet that I've just described, but also these lifestyle pieces incorporated as well.
And what did you find? Or tell me, I mean, I read it in your bio, but expand on the results of your
Yeah,
study.
for
And,
sure. Yeah.
and I guess incorporate as part of that answer how we should be testing kind of for our biologic age or for our DNA methylation. So again, listeners, if you've had your Dutch test done, this is a different test. That's more looking at just methylation of estrogen.
Yeah.
But if we want to look at DNA methylation, before we started recording, I was kind of asking you, well, who do you use to test? And asking about kind of the true age test. So incorporate testing if you can as part of that
Yeah,
answer, what the results
100%.
you found. Yeah.
So right now I will just say, I'll just cut to the chase and say right now we're using the PACE
Sure.
test from True Diagnostic, and you can get information from my website, younger-you-program.com,
Sure.
if you want to, but that is the one. Or you can go with the True Age test as well. They're both the PACE test is a little bit more affordable. It's a little bit smaller. The True Age is a mammoth test, and and the price point is a little bit higher, but the PACE test is solid. It's fabulous.
Good to know. Yep.
So we looked at DNA methylation. Yeah. So the huge question, we started our study back in 2017 and started and ran it in 2018 and 2019. The question was, this diet and lifestyle program that we put together, will it influence epigenetics? And at the time, 2017, 2018, you couldn't order a true diagnostic test. I mean, epigenetic testing in this way was just simply not available outside of the research center. And I just want to say we were given a full unrestricted grant from Metagenics to support our study. Yeah,
Awesome.
by the grace of God. I
Yeah.
know it's extraordinary, because we wanted to see, we've put together what we think is a well-designed program, but are we actually doing it? And so we were able to hire a clinical research center in my alma mater, Health Got Research Institute, out of Portland, Oregon. We also worked with McGill University and Yale University to conduct our study. And one of the first questions, so going back to what I talked about, when you look at methylation on DNA, there are changes, predictable changes that happen with aging that actually look like some of the chronic diseases of aging that we're vulnerable to. I mean, I know that sounds crazy, but aging itself is the biggest risk factor for the chronic diseases of aging, for cancer, for cardiovascular disease, for dementia, for diabetes. And when you look at epigenetics, aging actually looks like that. So those cancer genes that I talked to you about, that the tumor microenvironment will start to tweak, even in the aging journey, we're actually doing some of that tweaking, even without cancer. Like, some of those negative changes are happening. So we're able to predict biological age looking at DNA methylation patterns uh, uh, potently, actually quite reliably. The gold standard measurement of biological age is looking at DNA methylation in different patterns. So even though we came into the conversation on epigenetics through the lens of cancer and other chronic diseases, our first question was, are we influencing biological age at all? Because that's like the underlying driver
Sure.
of these chronic diseases.
Yep.
And so we were able to show, it was the first of its kind study, and it's why I'm here on your show, because it did get a lot of attention. And we were able to show in our 8-week time that, as compared to our control group who didn't have our study, our intervention, they got 3.24 years younger biologically. So the group that
In
followed our
eight
diet and life,
weeks. In eight
yeah,
weeks.
in 8 weeks time.
That's
Yeah.
nuts. That's awesome.
Yeah, it's really cool, and it was the first of its kind, and it got a massive amount of attention. I mean, I'm somebody who's educated other professionals. I have my own practice. I kind of, fly under the radar, but this certainly changed it. And it was
Awesome.
just one of the first very few studies to even show that biological age was changeable in humans. The very
Yeah.
first study had only come out in 2019. So extremely new science.
Well, now one of my listeners are going to want you to break down kind of all of what you already said, but maybe we can go a little deeper, which is in your book, which is very thick. I always joke about like my book being thick, but yours is really thick. Yours is like 470 something pages.
There's a lot of recipes in
Yeah.
there that you guys, and there's a big appendix. I don't want to like intimidate anybody from getting it.
So let me go back and maybe just let's go back to foods really quick. You listed off a lot of them, but repetition is good. So let's go back to
Yeah.
maybe 6 foods listeners can eat to
Hmm.
lower their biological age. What are the top 6
Absolutely.
foods? Yeah.
Yes. Okay. If you are willing to eat liver or take liver caps and
Yep.
get a clean source liver, so that would be like a New Zealand. Chris Kresser just came out with an organ product, encapsulated organ meat product, which is I'm taking it. That's what I'm using right now. But so either if you're willing to eat liver, do it. You don't need to do a lot. It's so potent. You don't have to go crazy with the liver. Just 3 ounces 3 times a week is plenty.
Okay.
And that would equate to about 3 capsules 7 days a week, so daily. Um, Liver is huge. Eggs are huge. Again, if you can eat them. If you can't, that's okay. You don't. It's not going to be a deal breaker. Shiitake mushrooms or maitake or anaki, so some form of mushroom. Greens. So whatever your darkest, the greens that you're willing to consume, and rotate around. Greens are important. And pumpkin seeds. I would say that, and let me throw in, actually, I'm going to throw in a few more. I'm going to throw in blueberries, I'm going to throw in green tea, and I'm going to throw in turmeric. So those are some from our dynamic dozen that we just think are cover the bases. And so if you can get those into your life on a daily basis, actually, if you can get them into your life a couple times a day, that would be amazing.
So for those who are sensitive to caffeine, if they can't drink green tea, if they're taking a green tea extract capsule, is that still going to be stimulating or not?
You know
Like,
what? It'll be a case by case basis. So I'm not a green tea drinker. Actually, let me say, coffee is also a methylation adaptogen. It didn't
mm,
make our dynamic dozen list, but for coffee drinkers in the world, you're okay.
that's surprising because I would think coffee would also deplete a lot of nutrients as well. Yeah,
People who drink coffee, decaf or caffeinated, live longer. I mean, study after study after study is demonstrating this, and not just a little bit of coffee, a decent amount of coffee.
and then my husband should
The
live forever because he drinks coffee all day long.
Clearly, the caffeine is the rate limiter, and it's something that will become a big problem for many of us, myself included.
Mhm.
I drink barely any caffeine. I love
Sure.
coffee. I love the taste of it, but I mostly just drink an organic decaf. I have a smidge of caffeine. So as far as green tea goes, I do capsules because I'm not a big green tea drinker, and I do think it's that important that it's part of my supplement routine.
Sure.
I take them in the morning, and I would just experiment. So if you're particularly sensitive to green tea or to caffeine at all, you may have a little bit of a stimulant effect from the green tea. But you know what? You can get catechins elsewhere. Like you're not,
Mhm.
behold,
Limited to, yeah,
there are plenty of really beautiful, potent epinutrients out there.
sure.
I should
Let's,
actually even look in the catechin. I mean, if you pop open the reference in the book, the nutrient reference in the book, you can look up
there,
catechins
sure.
specifically, and you'll see that there's a bunch of them.
Sure. Thank you. Let's go on to exercise. So, what can you break that down? We've talked a lot about not over exercising on this podcast because that can raise cortisol and cause other issues. But what is a good, in your opinion, recommendation for exercise, right, to help with aging?
We had a very modest exercise prescription in our study, and we'll individualize that. So now that we're past our first study and we're continuing to research, and don't let me forget to talk a little bit about some of our next findings. Um, we want exercise. The most important thing about exercise is just doing it.
Okay.
Like, it really is cultivating that habit that you're consistent with. Exercise is a longevity it is the
Promoter.
best
Yeah.
longevity pill out there.
Yeah.
It really is.
Yeah.
I mean, if you're a regular exerciser, not only will it prevent all of the chronic diseases of aging, it will actually extend life. We tend to think of disease prevention as life extension, but they're two different things. So it will shut down cardiovascular disease and cancer and dementia and so forth. But it's also demonstrated to actually tack on some years. So both phenomena can happen, and there are a few interventions that can do that. But exercise is essential.
So just
But
do it is what you're saying. Yeah.
well, in our study, we prescribed very simply a minimum of 5 days per week for a minimum of 30 minutes. Do whatever you want, achieve a perceived exertion. So this is by your own judgment of
Hmm.
60 to 80% of your maximum. So
Okay.
60% of your maximum is going to be a little bit of a brisk walk. It's not going to be crazy. You should still be able to carry on a conversation. You might have a little bit of light sweat, but it's going to be pretty easy. It could be cleaning your home. Actually, there's studies on house cleaning and methylation and showing beneficial effects to DNA methylation, which I think is really funny as somebody who's not into that. That would not be my choice. So do what you love, do what you feel like you can keep doing. You can go to the gym, you can go for a walk, you can go for a bike ride. That happens to be my main choice, but a minimum of 30 minutes, 5 days a week.
Okay.
Now, you can go up from there. I do think we didn't do it in our study, but high intensity interval training is
Hmm.
absolutely beneficial. And I touch on that in the book. And I think resistance training, maintaining muscle mass, we lose muscle mass as we age, so we want to maintain it. That is essential. But to your point about over exercising, it's funny. I took on a pretty aggressive resistance training plan over the last years, and I hit over exercising. I experienced it. And I've since pulled back, and I'm actually taking a week off of resistance training, and I'll go back doing it a little bit more gently. Over exercising is pro-aging. It's pro-inflammatory and it's pro-aging. And so, you want to pay attention to that. The
Sure. Sure.
vast majority of us, however, are under exercising.
Agreed. Totally agreed. I want to go back to food. I forgot. I was going to ask what foods appear healthy that may actually be having negative effects on our body long term. And then I skipped over that question. So can we go back to food for a second and you tell us what we should not be eating?
Um, biddy-bum, biddy-bum. Y I think our diet, it's packed every forkful is dense with these epinutrients. People will recognize them and know that they're smart, for other reasons, like we know turmeric is anti-inflammatory and anti-cancer and, antioxidant, et cetera, but they're epinutrients as well. The program is keto leaning, so the carbohydrate intake, the simple carbohydrate intake is kept low, so, clearly we're avoiding, um foods with a lot of sugar. You're not gonna find any major banana recipes, for the book, the study portion of the diet. Um, yeah, anything that's higher in sugar is pro-aging, even if it's a whole
Mm.
food. Like, or doing something like I mean, apples are fabulous and they're so dense with nutrients, but they're also pretty high in sugar. So you never want to peel an apple. And you probably if you're a little bit metabolically compromised, if your sugar tends to run higher, you're probably not going to be doing a lot of apples for a while. Um, we're not afraid of fat in this diet. There's plenty of it. And we think, especially choosing omega-3s and choosing some of the smarter sixes and saturates, we think are beneficial. Um, we in the program, in the study diet, and I'll distinguish that. We have a study diet and then an after study diet. We call it the Younger You
Sure.
Intensive, which is what we used in the study, and then we
Yeah.
move people onto the Younger You Every Day, which is a little bit easier. So the study diet was grain-free, no legumes. And so the reason that we did is if blood sugar isn't well controlled, these things can contribute to spikes. Also, legumes can, disrupt some guts. Uh, in the everyday, so when things are a little bit easier, if you tolerate those, absolutely eat them. I mean, plenty people who live long and healthy in this world eat legumes and eat grains. And so I'm not anti those, but in the intensive, we do pull them out. So that's some of the difference. It's a little, oh, and we do a very gentle intermittent fasting structure again, 12 hours on and 12 hours off of eating, just gentle. That little 12-hour window with the low glycemic diet plus the exercise will help produce ketones, which are potently anti-inflammatory, fabulous brain fuel, and they're epigenetic regulators as well in a beneficial way.
So what are your thoughts on low carb, low fat diet and epigenetics?
Low carb and low fat, so just very high protein,
Yeah,
really high protein. Um, that's a good question. I would say that there's not so a lot of this is new. I mean, I can't think of a study that looked at that particular
sure.
intervention. We've looked at caloric restriction. Caloric restriction definitely slows biological age, as measured by DNA methylation for sure. Time restricted eating seems to have a favorable effect. The Mediterranean diet does. Our program obviously does. Ours is sort of like a the volume is turned up. Ours is Mediterranean in some structures, but not in others. Um, I would say that if somebody is going high protein, very high protein, and missing some of the epinutrients that
Hmm.
that I've just talked about, um, it's not going to be beneficial for long.
So the
So
carnivore diet may not be the right way to go.
the carnivore diet definitely may not be the right way to go. I so being in a resistance training um, focused kind of path right now, I am eating more protein, but the epinutrients are so incredibly important
Important. Yeah.
that what I'm doing is toggling. So I've got a day where I hit all of my younger U targets, and then on days where I'm weight training, I hit a higher protein with some of my targets. So I'm being careful. I'm toggling it. In fact, I just wrote a blog that we'll be releasing that people can read on my thoughts on protein. I think the carnivore diet and some of these extremely high protein diets, I think we're going to see fallout. I think that we
Hmm.
will end up seeing patients coming to our practice
Hmm.
who are malnourished
I
because they've
agree.
been
Yep.
focused excessively on protein. I actually
Even
have
even
no
if they
doubt.
feel better in the short term, right? I
Hmm.
mean, I'm thinking, oh, they're removing all these inflammatory foods, so they're kind of
Yeah.
resting their gut in a way. So sure, they could feel good in the short term, but in the long term, I
Yes.
don't think it'll pan out. But we'll
That's
find
exactly right.
out. Yeah.
Yeah. Yeah. You're exactly right. So if somebody wants to do this, because a lot of us don't get enough protein, we need to do it consciously. And for a lot of us, this will require a support of a nutritionist to make sure that we're getting all of the other nutrients that we need. We might even need to supplement. I mean, you just don't undertake that kind of a change cavalierly, and if you do, which plenty of us do, if you do it for a long time, yeah, you'll run into some problems for sure.
Well, I want to go towards supplements for a minute here. So you've kind of already, there's so much overlap between the foods and the supplements, like turmeric, right? You can literally eat that, but it's also a supplement. There's
Yeah,
overlap there. But
yeah.
for patients who, let's say, read your book, get your cookbook, they're they're for the most part, they've made important changes and they're getting a lot of these nutrients. What top supplements should they still consider? So I know in your study, I think you had the participants on greens and probiotics. Is that right?
Mhm. Yeah, we had a
So
greens powder, so extra methylation adaptogens. Actually, it was greens, it had a little bit of flax, it's got, raspberry, and I think it's got a little maca, and, it's got those methylation adaptogens that I'm talking about.
okay,
It was a greens powder, and that was from Metagenics. That's phytoganics from Metagenics. And then we
sure.
did a probiotic. Now in the book, we're recommending people consume fermented foods, but we
Foods,
didn't have
sure.
that in this study just because there's only so many things you can do in a study before it's just overwhelming.
Right.
Um, we need to take care of our gut. We need to be taking care of our microbiome. All of those epinutrient foods are going to be microbiome superstars. But we did an additional probiotic, that particular one, because it's known to be able to support production of folate. So a good, healthy gut microbiome will produce many different vitamins, including folate, B12, but biotin, and some of the other B vitamins. So as long as we have a healthy gut, we're going to lean on that for some of our folate. And we did, without supplements, increase circulating folate significantly in the study participants as compared to control.
That's
So
awesome.
it's so
Yeah.
we did succeed in doing that. I don't know how much of it was the probiotic versus the diet, but we definitely did do that.
Improved it. Yeah.
So those 2 supplements we used in the study, and people are certainly using those who are following the Younger You intensive. Everybody needs fish oil. I mean,
Hmm.
really, who doesn't need
Hmm.
fish oil? Vitamin D, another workhorse nutrient. Take it with K. Take it with
Hmm.
K2. It's easy to do. Um, most of us need magnesium, so grab magnesium. And
Yep.
yes, if you're not getting turmeric routinely, if you're not eating like a good thick curry every single day or multiple times a day, take some, say, take some turmeric. That's easy, some green
Sure.
tea. So I think the workhorse nutrients most of us need are D, and D, take it with K, fish oil, and magnesium. I go through quite a few other supplements in my book that um, that
Yep.
people can consider taking.
Well, I wanted to circle back around to two things here. One, those kind of that backdoor approach to methylation that I had mentioned a while back, but I also wanted to ask you about senolytics. And so what those are, you've kind of already mentioned curcumin and the green tea extract. But can we talk
Yes,
about both of those things real quick?
resveratrol,
Yeah,
quercetin. Yeah,
first fill
these
me.
are
Yeah.
guys. So as we age, we tend to we increase production of senolytic cells. These are zombie cells. These are pro-inflammatory white blood cells that just kind of hang around and wreak damaging havoc. Um, they have actually they have their pro-inflammatory effect actually has some limited beneficial effects. It can keep certain cancers. It can, there can be some side benefit to them, but in general, we have way too many of them. And so it's just part of the inflammation phenomena, this chronic and low-grade inflammation that's happening in our bodies that just drives aging forward and accelerates it. So we don't want these senolytic, these zombie cells hanging out. And the way that there's a number of foods. So intermittent fasting or
Hmm.
time restricted eating or even frank full fasting can turn off these zombie cells that can cause them to break down and be eliminated by the body. So that's fabulous. But there's also nutrients as well, and you pointed out some of them. Quercetin is very well known.
Yep.
Fisetin in strawberries is another one that's well known, and has been studied. Resveratrol. Um,
I think we
what
named
else?
most of the ones I know at least. Yep.
Yeah, and so, for these are the compounds, the methylation adaptogen epinutrient compounds are what we call pleiotropic. So a handful of them are potent senolytics. We'll discover more that are senolytic. They're anti-inflammatory, they're anti-cancer, they're antioxidant, and they regulate epigenetics. So they just do a lot of very important stuff.
Sure. Thanks. Let's go back to that backdoor approach to DNA methylation. So rather than giving methyl donors, what is this approach?
Yeah, so for people who don't tolerate supplements,
Hmm.
certainly most of us, if any of us have been practicing long enough, or maybe we know someone who you give them B12 or folate and it
Hmm.
produces anxiety or um, just causes some untoward symptom that prohibits them from being able to take them. I had actually a patient who I worked with. He's in the book. Had a experienced really profound neuropathic pain with any amount of B12 or folate and delivered in any dose in any route.
Mm,
So injections, sublingual, just all sorts. He couldn't handle it. Um, there's 2 pathways in the body that are methylation intensive, like incredibly intensive. Choline is an essential nutrient for brain health, um, for lipid membranes, for a variety of reasons, for methylation. But it takes to make choline. It's a super energetically demanding process in the body, and it takes 3 steps of SAM. So going back to that molecule SAM that we make in the methylation, it takes 3. I don't know that there's any other pathway in the body that is so methylation demanding, but choline is. So even though we can make it in the body, it's considered to be conditionally essential because many of us don't make it well. And then there are mutations in the enzymes in the choline synthesis pathway that some of us have, and so we have a double or triple whammy. So choline is a backdoor methyl nutrient. People aren't going to react to it the way they do to B12 or folate. It's not going to cause jittery or anxiety or pain. You could do this with eggs, you could do it with mushrooms, liver, or you can actually give them supplemental choline. And that is one way that's one of the backdoor methylation
to spare methyl donors.
options.
Sure.
And then the other way, there's two other ways, but the other major way is muscle, again, muscle breakdown, creatine. Making it is methylation intensive. It's only a single methylation step, but because our bodies have tons and tons of muscle, we turn it over for energy. And so we can, another backdoor methylation is to actually supply the body with supplemental creatine, and so that we're not using methylation to make it and recycle it and make it and recycle it and make it and recycle it. So we can preserve methyl donors by supplementing there. And then the other thing is stress reduction. I mean, if our adrenaline is always up, we will divert methyl donors to metabolizing that. So that's a methylation step. And our body is just going to be putting a lot of attention into moving them out of the body. So if we can engage in some stress reduction, I mean, even estrogens, like if we're in an estrogen dominant state, men or women, for whatever reason, if you control that, you're going to be turning down the volume on the methylation demand from that pathway step. So it's just kind of coming at the biochemistry a little bit backwards. But I would say the two biggest backdoor methylations would be, choline and creatine, and then followed by working on stress.
Sure. I think I didn't plan to ask this, but I feel like I'd be remiss if I didn't ask about MTHFR variants on a methylation podcast. But I, like you mentioned in your book, patients come in and they say, I have this dreadful MTHFR gene, I'm going to die early, and they freak out and kind of overreact. And as we open the podcast, you were saying, well, your genes actually aren't your destiny. But I want the listeners to hear it from you. Just having one of these genes, it isn't a bad thing. Like, a lot of people have these genetic variants, right? So maybe expand on that and kind of share the good news.
Yes. There's actually two interesting pieces, and I do talk a little bit about MTHFR in the book, but we are really in the driver's seat of whether or not we live a long, healthy life. Like, it's up to us. We aren't victims of our genes. For some of us, we're going to be rejoicing. This is very empowering. We're excited about taking control. For some of us, we're going to be like, oh, shoot, I'm going to have to work at this. It's kind of funny. I mean, I think we encounter both. Most of the people I talk to in interviews are, like you, and really excited that, like I am. This feels very empowering. My family, there's loads of cardiovascular disease and diabetes, and there's some obesity, and it's pretty nice to know that does not and is not my destiny. MTHFR is interesting because, it does compromise methylation. There's some very limited suggestion in the literature that biological age could be a little bit older in women only. Interestingly, this hasn't been reproduced. Actually, maybe there's some preliminary research that suggests it could be the case in men. So MTHFR demands more attention to methylation for some. For others who are heterozygous for the 1298, which isn't wildly influential, we're not going to see any difference. But for some of us, it could change DNA methylation in such a way that biological age could move a little bit faster, but it's imminently resolvable. It's very, very correctable. One study showed supplementation with B vitamins corrected it and lowered bio-age. Our study suggests that you can do the same thing with diet. So
awesome. Yep.
So for some folks, you're going to have to pay a little bit more attention to methylation, but is it a life sentence? No, it's very correctable.
Good news. Good way to kind of wrap up the show here. So tell us, well, first tell us about your cookbook and then kind of tell us, you have this quiz, this biologic quiz. So yeah,
Yeah.
expand on both of those.
Okay. This literally just as I was telling you, you're the first person to see it. It just came in the mail. My office manager texted me a photo of it when I was at home. It's gorgeous. It's just
It is.
beautiful. And this is you can drink your epi-nutrients with the better broths and healing tonics. So all of those beautiful nutrients that I'm talking about, you can just, mix up and put in a beautiful broth base and consume all of these longevity nutrients packed. And then we have all sorts of additional recipes, mains, there's desserts in here. There's all sorts of like sort of food recipes, not just the broths, but all of the recipes call for using these really important epinutrient dense broths as part of them. So it's just a really cool, beautiful, beautiful book. So for free, you can come take the BioAge quiz with us over on our website, and that's just youngeryouprogram.com. And you'll see the BioAge quiz right there on the homepage, or you can go youngeryouprogram.com/BASA and find it. Just head over to youngeryouprogram.com and you'll find everything. You'll see the book, you'll see the broth book, you'll see our BioAge quiz, and
Awesome.
if people actually want to get the blood test, you'll be able to access the blood test for the BioAge as well.
Good to know. Good to know. Well, tell me as we wrap up the show, I mean, this whole episode has been on aging well, but what's your top longevity tip? If you had to pick one, what would the top tip be?
I would say that my top tip for longevity is something that we didn't study. It would have been awesome if we could. And that is community and connection, I'll just say connection, and whatever that way is for you. I think that's probably the most important longevity.
I've had one other guest have similar opinion. So I think you're onto something there. How do we study that? I don't know. But yeah, I think you're onto something. I agree. Good tip. Something different.
Yeah.
Well, thank you so much today for coming on the show and sharing how we can improve our DNA methylation and turn back the clock on aging and really just live longer, better. This is awesome. Thanks so much.
Thanks for having me. It was fun.